action.
Hello, boys and girls. This is the course of environmental science, which is meant for BTech third year and fifth semester. The code for this particular subject is AMC 501. As you know, this is the mandatory course of BTech third year, and I am G Chakravorty from Department of Chemistry, welcoming you to this course of environmental science.
So let us have a little bit prerequisite knowledge that you people are having. So basically, we started from the lecture 1 to 6, which belong to general part, and after that we started air part, right? 7, 8, 9 lectures we have seen, and all those 3 lectures were part 1, part 2, and part 3 of the air and its pollution, right? And now today, as you can see, we are doing the part 4, right? Now in part 1 we have seen the different types of layers present in the atmosphere, that is the 5 layers that we people are having, including each and every details, minor major details of each of these layers, right? Whenever we are considering lecture number 8, we people have seen that there are different uh, effects of greenhouse and global warming, right? So greenhouse effect and global warming we people have studied in that particular lecture, which is named the air and its pollution part 2. After that, in the last lecture, there is lecture number 9, there is part 3 of air and its pollution. We people have seen that what different type of pollutants are. The lecture was very important, that there are 2 different types of pollutants basically, that is primary and secondary. And the primary pollutants are those which directly are emitted into the atmosphere, whereas the secondary pollutants are those which are derived from chemical reactions in the atmosphere, right? Examples accordingly we people have seen, how these are formed, that also we will have seen, and what the effects of this particular things are, that also we have seen. But after this, there was one of the most important topic, there is a criteria pollutants, because these are the pollutants which are the main villains, right, main culprits of the environment, and as they pose a substantial threat to the nature, and they cause huge pollution, harmful pollution. Now the 6 criteria pollutants, each and every one we people have discussed in brief, that how they're obtained, what are the physical chemical properties, and how they can be controlled, what are the ill effects, everything we have discussed, right? Now it's time for part 4 of this particular lecture, and as you can see that this lecture is dedicated to the thing which is called smog. Okay, so we will be studying the details of smog from this particular lecture, and we'll see what photochemical smog is, what London smog is, and what are the differences between this particular 2 type of smog. Okay, so let's begin our journey, and if we go for the fact that what smog is, right, what is the answer that we people are getting? This is the answer we people are getting. We can see a huge thing is written. You might be thinking that what the huge thing is, right? Let us go into the thing. See, smog, if normal, um, we want to make out a meaning of this particular word, we will say that it is a combination of smoke plus fog. Okay, SM from the smoke and OG from fog, right? Smoke plus fog means smog. Okay, but apart from this particular thing, right, there are huge details about smog that is very important for us. Okay, so we need to see those details carefully, right? And those details says that photochemical smog is also appearing in regions of the tropics and subtropics where savanna grasses are periodically burned, right? Okay, now you might be thinking why this thing is written here. Basically, little bit details about the type of smog, the history of smog, and what is smog. All these things are present here. Okay, now smog's unpleasant properties result from the irradiation by sunlight of hydrocarbons caused primarily by unburned gasoline emitted by the automobiles and other combustion sources. Okay, what does that particular line means? It means if you are burning fuel inside an automobile, what is happening? If it is complete burning, it's fine. If it is incomplete burning, then the total fuel, uh, whatever particulates are left behind, that thing will come out as smog, and that smog will create some problem. Okay, now it depends on the type of smog, that how it will affect and how adverse the effect will be, right? But truly speaking, smog is not good for us because it creates huge problem. Now what type of problem, that we'll see accordingly in this particular lecture. Right now here we are first going to see that what the important facts about smog are. The products of photochemical reactions include organic particles, ozone, aldehyde and ketone peroxyl acid nitrate, organic acids and oxidants. Ozone is a gas created by nitrogen dioxide. When exposed to sunlight, ozone causes eye irritation, impaired lung infection, etc., etc. Right? And this type of smog is also called industrial smog. Okay. So basically, as we can see that smog is created by public activities as well as by industries, right? Now, if any industry releases substances that actually reacts with ozone or peroxyacyl nitrate and organic acids, aldehydes, definitely they're contributing towards the formation of smog, right? And in this case, if the smog is generated from an industry, then the type of smog will be called industrial smog, right? But whenever we will see the details, we do not see any special type called industrial smog. Rather, we people will see the different type of smogs, namely photochemical and London smog. Okay. A smog is created by burning coal and heavy oil that contains sulfur impurities in power plants. Okay. See, if nitrogen impurities are burnt, then one type of smog will be formed. Sulfur impurities are burnt, another type of smog will be formed. At this moment, I will not say what the type of smog will be. Let it be a suspense. Okay. Right now, industrial plants, etc. Okay, the smog consists mostly a mixture of sulfur dioxide and fog. If sulfur dioxide and fog together they are doing something, then it is actually called smog, right? Suspended droplets of sulfuric acid are formed from some of the sulfur dioxide and a variety of suspended solid particles. Okay, this smog is common during winter in cities such as London, Chicago and Petersburg. Okay, so in this particular cities like London, Chicago and Petersburg, the smog of sulfur dioxide is quite common, and it also happens during winter, right? Now when these cities are burned with large amount of coal without control of the output, large problems are witnessed. Okay, so when nothing was taken care of and huge amount of coal was burnt, then people living in those cities faced problems. Right now in 1952 a huge incident took place in London, England. There is 4,000 people died as a result of this form of fog. Today coal and heavy oil are burnt in large boilers with reasonably good control or tall smokestacks, so that industrial smog is less of a problem. See, basically if this smog problem happens, what will happen? The thing will move into our lung, right, through our nostrils and nose, and it will choke our respiratory system and will die, right? And this type of death actually unfortunately happened in 1952 in the city of London, right? And around 4,000 people died in that particular incident, and it was later found that the thing actually the smog originated from industry. Okay, but nowadays that's why, due to avoid this huge loss of life and property, what happens, the oil and coal, whatever is to be burnt, it is burnt in specially designed containers which are called boilers, and also they use long chimneys so that these problems are eradicated, right? Now some countries like China, Poland, Czechoslovakia and some other Eastern European still burn large quantity of coal without using adequate control. Now, we'll not go into the details what China does, because we know that what we are facing due to China is the sole responsible country for which we are facing this corona problem, right? Also, multiple problems have been imposed by us from China. Okay, so anyway, let us go to the next topic, which is one of the main topic of this particular lecture, that is photochemical smog, right? Now here, the name implies photo and chemical. Means photo means sunlight and chemical means chemical. So here it is clearly indicated from the name that what will happen in presence of sunlight, some chemical reaction will occur that will result in the formation of smog. Okay. Now photochemical smog is also called summer smog. This is very important for us. Photochemical smog is also called summer smog, and it reacts in presence of sunlight, that is nitrogen oxides and volatile organic compounds in atmosphere, and creates problem like it results in airborne disease and formation of ground level ozone. Okay, now it depends on primary pollutants as well as on formation of secondary pollutants. So this type of smog is dependent on both primary as well as secondary pollutants, right? Now, what these primary pollutants are, on which it depends? See, these primary pollutants are oxides of nitrogen, basically NO2, right? NO2 is the basic thing on which this particular smog depends. Okay, this is followed by nitrogen dioxide, or in previous was NO and this is NO2, right? These two are the different types of this primary pollutants on which it depends, whereas this peroxyacid nitrate is the main secondary pollutant, along with tropospheric ozone and some aldehydes. Okay, but believe me, peroxyacid nitrate or PAN is the major pollutant, secondary pollutant, that is the result due to which this particular photochemical smog forms, right? So basically, it is nitric oxide, nitric dioxide, and peroxyacyl nitrates. Okay, this together creates this particular huge problem. Now, an important secondary pollutant is ozone, which is formed when hydrocarbons and nitrogen oxides combine in presence of sunlight. Okay, so another important thing is ozone, which is formed due to the reaction of this and this, right? Which is formed due to combines the oxygen in air. In addition, SO2 and when SOx and NOx are emitted, they eventually are oxidized in the troposphere to nitric acid and sulfuric acid. Okay, so this actually results in the formation of another topic that we are having, that is acid rain, right? So basically, this particular oxides, they react with water to form acids, which falls down to our head as acid rain, right? Okay, so that is what it is written here. You can see the thing acid rain is written here, but we will not discuss about it here because we have a devoted lecture for this particular thing. Okay. Now, all of these harsh chemicals are usually highly reactive and oxidizing. Photochemical smog is considered to be a problem of modern industrialization. See, if industry increases day by day, then this will happen, but it is not that the industries will not grow. Industries need to grow, otherwise economically we will never be ahead of somebody. But problem is, if industries are growing, precautions must be taken, right? If proper precautions are taken, no problem will happen. Okay, now in present in all modern cities, but it is more common in cities with sunny, warm, dry climates and large number of motor vehicles, because it travels with wind and it can affect sparsely populated area as well, right? So whether your population is small or big, it doesn't matter. It is present in all countries now. Okay, so you can gradually see photochemical smog in any place. It is available in all countries, right? Now, if we go to the fact, you can see in the background a beautiful picture of photochemical smog is given, right? Now, this picture is beautiful. The thing is not beautiful, but the picture is quite amazing. Okay. Now, how photochemical smog is formed and what are the corresponding reactions, that is clearly mentioned here. That NO2 reacts with UV radiation in forms of light, that is proteolysis occurs, and it results in the formation of NO, and from where it reacts with ozone, right? As we can see, I'm discussing this one. So it reacts with ozone to form this particular reaction. Okay, right? So NO plus O3 will give NO2 plus O2. After that, what will happen? This O2 will catalyze this particular reaction, and gradually we will get something else. Okay, finally we will get this particular thing which is called peroxyacetyl nitrate or peroxyacyl nitrate, that is PAN, right? This PAN is not permanent account number that you are having of income tax department. Rather, this particular PAN is peroxyacyl nitrate or peroxyacetyl nitrate. Okay, so remember this very well. This is very important for us. Let us go to the next slide. As we know that already we have discussed a little bit about the London smog, and now we'll go into the details and we'll see what London smog is and what photochemical smog is, right? So let us see what the details are. So as we can see, the Great Smog of London, I don't know why it is called the Great Smog, because it killed so many people. So why it is considered great means dangerous, I guess, in this particular sentence. Okay, it was severe air pollution event that affected the British capital London in December 1952. Okay, December means winter season, right? Period of usually cold weather, anticyclone, windless collected airborne disease. Okay, thick layer of smog over the city. It was formed from Friday 5th December to Tuesday 9th December 1952 and dispersed quickly when the weather changed. Okay, now fine. This is the time span for around 5 days. The smog was there. That is from Friday 5th to Tuesday 9th of December of 1952. Right. And this particular smog is called London smog because it was formed in London for the first time. Okay. Now this caused a major disruption in reducing the visibility and penetrating indoor areas. Okay, fine. So everything was invisible, and okay, peace was fine. Government medical reports in the following weeks, however, estimated that until 8th December, 4,000 people has died as a direct result of the smog, and 1 lakh were made ill by the smog effects on the respiratory tract. Yes, if somebody is having respiratory problem and if this particular smog enters their lung, then definitely they will die. Okay, if they're not dying, then definitely those who will not die, they will be in having a huge problem regarding the respiratory system, right? Okay, the more recent researches suggest that the total number of fatalities may have been considered greater on paper, suggesting 6,000 or more. Wow, my God. London has suffered since the 13th century from poor air quality worsened in 1600. Okay, fine. This is just a history about the London we are not concerned about, right? Most significant in terms of its effect on environmental research, government regulation. Fine. Acha, depending on this particular thing, the government has implemented the Clean Air Act in 1956. This is worth studying, right? So, Clean Air Act was imposed by the government in 1956. Okay, and the smog took place 4 years ago in 1952, right? Now you can see this is a picture, our very own picture of London smog, though this is not London, this is our own Delhi, where you can see the India Gate in the background and people running away with mask. Now this particular mask is not for corona but for the smog. Okay, so India Gate, you can barely see the view of the India Gate, which looks so beautiful. I myself have been in India Gate. It looks so beautiful. But the problem is, if it is smog, then you can barely see this huge building, right? Okay, that much dangerous it is. Now, as we know that this London smog is formed due to the oxides of sulfur and all, right? So what different type of oxides of sulfur can cause it, and what different reaction actually occurs, that we are going to see here. Okay, so SO2 plus half O2 gives us SO3, and SO3 plus H2O gives us H2S, right? So basically the reactions are almost similar to that of acid rain, and what happens basically, this actually forms contacts with water, to form a dusty type of thing, which is actually called smog, right? Okay, so this was all about the sulfur smog, but the main important thing that comes in exam is right in front of you. We need to understand this very well because this is very, very important for us, right? What are the basic differences between this London smog and sulfurous smog, right? If we go to for the first point is what discussing as a difference that the photochemical smog was first observed in LA, that is Los Angeles of USA, whereas the London smog was first observed in London, that is UK, and it was named after it, right? So the first point is very, very easy. You can easily remember it. It is behind the name of these two particular places, right? Though photochemical smog is not is also called Los Angeles smog, but another important name is there, that is photochemical smog. So if you say Los Angeles smog, we'll say London smog. If we say photochemical smog, we'll say sulfur smog. Okay. Now, main components, we have already discussed this in brief, that oxides of nitrogen and ozone are the main components. Along with that, there are small amount of hydrocarbons. This is the reaction where this particular oxides of nitrogen reacts with gases and sunlight to form ozone and NO2 and PAN, right? On the contrary, if we see the reactions for sulfurous smog, we will see whatever we have seen that are written here, that how H2SO4 is formed by reaction of SO3 and water. Okay, right? So this particular example is about the reactions and components. Next is the next point is very, very important for us, that photochemical smog proceeds with free radical mechanism of the PAN formation, and the sulfurous smog may or may not proceed through free radical mechanism. Okay, so it may proceed through free radical mechanism, it may not proceed. Okay, nobody can control it out. Right, next we are having that this is oxidative type of smog, this is reductive type of smog. Okay, so photochemical smog will cause oxidation, whereas the London smog will cause reduction. Okay. Fifth one is PAN is the main byproduct, sulfur salts are the main byproduct. Yes, here PAN is formed, here sulfur salts are formed. Next, it is, as we have already studied, that in summer, midday summer, the photochemical smog occurs, whereas in the early morning of winter, the London smog occurs. Okay, right? And most adverse effect is eye irritation, whereas here the most adverse effects are lung and throat irritation. Okay, so this was all about the differences of photochemical and London smog. So in this lecture, we have seen what is smog, right? And what are the details of smog, what is the history of smog formation, what is photochemical smog, what is its history, how it is formed, what are the main products and byproducts, and similarly we have seen for London smog also, right? And in the end, the very common question which usually comes, that what are the differences between photochemical and London smog, that also we people have clearly discussed. Okay, so this lecture will end here, right, as we have completed all the topics that were designated for the day. So thank you so much for watching this lecture, and in case of any problem, just note it down, we'll discuss and we'll solve it out. So till then, you just stay healthy, stay safe, stay happy, and save environment, right? So let us see for the next lecture, lecture 5. Until then, thank you so much, have a great day. Thank you.